Okay, hi everyone. Welcome to Hacky Hour. For those of you who are new to Hacky Hour, these are designed for our community of developers. So you can come out here and ask us questions about the topic at hand or any other topics related to your computer vision project. So we highly recommend you maybe like raise your hand. You can use, there's a raising hand button in Zoom, or you can use the Q&A button using the Zoom application, and we can take pauses throughout our presentation and take your question and address them live. So with that said, today's topic is how to use TensorRT models for your computer vision applications. And for those of you who don't know me, I'm Komal Devjani, a developer advocate with AlwaysAI, and I'm here with Steve Grisette, probably everyone's favorite presenter. So welcome, Steve.
I know, Lila's pretty good, so.
They're all good, but you seem to be the crowd favorite.
Okay.
All right, so let's get started. So I'm just going to show you how to get started with AlwaysAI if you're new to the platform. So what you want to do is go to alwaysai.co and sign up for an account if you haven't done so already. If you have an account, what you want to do is simply sign in and navigate to your dashboard. On your dashboard, you will see some of our popular starter apps, a sample project you can get started with. You can create a new project, learn about how to set up your edge device, be it a Nvidia Jetson device or a Raspberry Pi. And you can also download the CLI directly from the dashboard. So this is like the most critical part of getting started with AlwaysAI. So you just want to click install CLI, pick your operating system, hit next, and then you will have a nice big bright button to download the CLI for your Mac or your Windows, whichever one you're using. So let's just go ahead and create a new project today. We're going to run a simple object detection. So we'll just call it Hacky Hour, TensorRT. I'm simply just going to show an object detection. So I'm using this for reference. Now we can go ahead and view our project. And as you can see here, like once you're viewing your project, you can, of course, download the CLI. You can navigate to the model. So we already have a default model of MobileNet SSD. You can add collaborators to your project and then add devices. So for me, at this point, I'm okay with using the MobileNet SSD model. Just need to make sure that my app.py files will support that. So we're going to copy this and then navigate into our terminal. And I'm already in my directory, so we can go ahead and configure this project here. And then I want this on my local computer. All right, with that done, let's go to Atom. And here is, I already have my app.py file open. So here what I want to do is make sure that I have this command. So I just navigated to the model MobileNet SSD. I have this command specified in my app.py files so that this is the model that we will run. So we're specifying the class of computer vision we're going to use and then which model. So from here, let's go back to our terminal and then we can do AAI app install. And then AAI app start. Okay, and it looks like this is the model it's running. So it shows here that this is the MobileNet SSD model. And we're going to copy this link. As you can see, open up a new browser, paste the link. As you can see, it can detect me. I can detect my potted plants in the back. And that's how you know your CLI is working properly. So today's focus, as we know, is how to use TensorRT for computer vision. So we're just going to go ahead and start these slides, and I'm going to hand it over to Steve to take it off from here. Steve?
All right, thanks. So everyone, hello. And I think you have the slides.
Yes.
So I'm going to let you do that. Otherwise, we use the unofficial Steve format, which probably has spelling errors in it and everything else. We don't.
Are you able to see my slides?
Not me, but that could be my problem.
Oh no. Okay, let's see. What about now?
Oh, definitely now. So
okay, perfect.
We can definitely see that. So yeah, hello everybody. Welcome to Hacky Hour. I got my Python cup drink, and I'm drinking some coffee today, so that's what I'm up to on it. So if you noticed, Kamel ran on a MacBook, I think MacBook Air, was that correct?
Yeah, MacBook Pro actually.
Yeah, so it ran about 55 milliseconds for its inferencing times. And so we're going to smoke that today with some edge devices. So we're going to go a lot faster than that. So TensorRT. So let's go to the first slide. We can. So on the AlwaysAI platform, we have really two different ways to address a NVIDIA GPU. So we've built what we call a CUDA interface. So if you use our backend, we access actually the CUDA library. So they have a C interface, so we attach that C interface, and we can allocate the models over to that CUDA interface, and that CUDA interface will take care of distribution of the models and so forth. And the advantage to this approach is you can pretty much go to our model catalog, and you can basically choose most of the applications that are out there, or models that are in that catalog, and use them with the NVIDIA processor. So it doesn't get really specific to the CUDA implementation or Jetson architecture. So it's a great way to deal with a high set of models, and even one that you may create and so forth using our model retraining. You can go back into that CUDA interface. So it's a nice way to do things and so forth. And so we have an example I did a couple weeks ago, but there is up in our Git, and that's the address for it there on this slide. There is a set of CUDA applications that take you through everything from classification to semantic segmentation and so forth, showing you how to use that interface. So there's an example up there. Now, for some of you, may take a look at this and say, wow, man, I tried it back with earlier versions like Jetpack 4.3 or Jetpack 4.2 and so forth, and it was faster. There is a regression bug, NVIDIA regression bug in version 8X of the CUDA interface, specifically their inferencing engine. And basically it will slow things down. So our recommendation, if you're going to use that CUDA interface, that you base yourself on Jetpack 4.2, and you use our Edge IQ version 15.1. So the current version is optimized to use or less than optimized to use Jetpack 4.4. And so in the previous video, if you go back in that, I show people how to do it. But the easiest way is just join Discord. And when you join Discord, just go ahead and you can put it up, and any of us can lead you through the process to using that Jetpack 4 and using that backend system. So that's the past. That's how we showed you in previous ones. That's a way to use a lot of different type of model architectures. The next way to interface that we support is something called TensorRT. Now, and specifically we have, and I use this very loosely, we have models in object detection and pose estimation. And the reason I use it loosely, the term model, is because these are really binaries that are compiled down based on models. So and they will even execute on a specific Jetson device. So when you're going to our catalog and you're getting you can sort on that device, and it'll show TensorRT models. And our TRT is the preamble we put on those models, and then the last piece is the hardware that it uses, a Nano, a Addavier, or a TX2 type of model. So you have to be very specific as you use these models on them. And again, it will pull these down into a binary to execute. And what it does is it basically will provide a plan of execution for that model or inferencing on that Jetson device. So how is it going to execute, allocate things across the CPU and the GPU and so forth. So it's very tightly coupled to that architecture on it. But what the results are, and some of the things it does is we do compression and layer replacing. So there's plugins and so forth and go into this. So there's also so that's the piece. But the good news is, just like you do, and we're going to start this when we go through the demos, but you can utilize and use these backends through our APIs. We will custom compile your models if you're using today our model retraining. We'll go ahead and compile these models. As a matter of fact, 2 of the demos I'm going to show you are on models created with our model retraining, so that we can do that piece for you and so forth. So that's it on kind of the preamble. Let's go into what a couple other things I want to do and talk about jets and devices. So the next thing is, you also have to there's some Nvidia command line Linux commands that you should learn to do if you want to get the most out of your devices. So one of them is on the first one, if you're using like the Nvidia Nano, and that's the first commands, and that's what it should say. It says Nano CLI commands. So the first one, and it's true on both of them, is the power management set. So if you want to get the power, so these things eat a lot of power and so forth, and they come up in a more efficient ways and more optimum ways. But if you want to maximize, what you want to do in the case of the Nvidia system, if it's a Nano, you want to set that power management system to 0. It also has something called clocks, and clocks affect the fan operation, but they also, on the cores that you have, by setting the clocks, these cores are going to run all out. They're going to go up to whatever the different, so 1.5 gigahertz or whatever it is with the Nano and so forth, and the Addavier, it will run those out. So they have 2 different sets of commands. So you're going to want to SSH into your systems, and we'll go through that on the demos and so forth. And we'll show you how we'll run those commands and so forth on it. So now I think I've had that preamble. I've talked. Do we have any questions out there that I need to get to?
Yeah, there's a couple of questions. So there's actually like an error report. So someone said that I ran the command and saw this error.
You should see a warning, and that's different than an error. But go ahead. So why don't you describe it?
Yeah, it says your authentication client is not signed in. That's the error.
I haven't seen that one before. Okay, we'll have to take a look at that. So, if they can go on, I don't know if we have anybody like Tiger or Eric on. They may have seen. I have not seen that particular error on it.
I don't think we have Tiger on.
Okay, so what we should do is take that question and get back to it. So that's a good question. I haven't seen the error. Doesn't mean it doesn't exist. If we can get a little bit more detail for the thing on what platform that was run on and so forth.
Yeah, and then AB, just for your reference, so he's asking what the error is. I've posted what the error is that our user's reporting on our chat window. So you can take a look. So there's a question here that says, do you think that AlwaysAI will be expanding on the models tailored to NVIDIA GPU devices?
The answer is yes. So we're going to target for sure the low-hanging fruit. What's missing in the SSD field that we currently have is we're going to add Inception SSD right off the bat. So different architectures within object detection. Let me do this. And then we're going to expand it out into RCNNs, mask RCNNs, and semantic segmentation as we're going forward. Those make the most sense. So this is step 1 in this process. So first it's pose estimation, followed by SSD object detection. And then within object detection, we're going to expand. For sure, we're going to do SSD. We're taking a look at YOLO. So we're going to get those out there, and we'll continue to expand that portfolio and move into other things. So
thanks. And then he also said excited for FRCNN.
Yeah. So we're gonna do this. This is just step 1.
Okay.
All right.
One more question.
Sure.
Is I think this is a more broader question, but I think you'd be great to answer it. It says, does the GPU have features, or is it specifically designed for AI? So does it have, I think does it have features that support
So,
AI, or is it designed for AI?
so GPUs made their mainstream in graphical processing, obviously, and the big users of that in gaming, right? So they've been invited. So they also have usages inside of model training. But what makes model training interesting is the model training and execution. So AI. So what makes it interesting is its ability to do the floating point math, and CUDA is especially interesting in this area because of its ability to have the CPU directly access the GPU and have a shared memory component and so forth. And it allows you to operate that GPU CPU combination in a very efficient manner. So the CUDA system itself has an inferencing engine called CUDNN that knows how to really exploit those types of things. So it gives a benefit to the AI. But GPUs in general are a general purpose floating point unit and so forth. Unlike our Myriad, which we use, which is specifically tailored chipset to run only AI models. A GPU can do a lot more to that. It can help you with statistical processing and things like that are out there. So.
Cool. No more questions, Steve. I think we're ready to move forward.
All right. So I think we have one more before I go into the wonderful world of demo. So I want to go through the code examples that we're going to do. So we're going to do object detection, and there's a lot of people who've asked how to use the CSI camera on the Jetson platform. So we're just going to cover that briefly so you can see that. And what we're going to do with the object detection is Como set us up perfectly. She did a generic object detector, and that's what we're going to do. And we're going to morph that into a TensorRT system. So it uses the TensorRT to execute against Nano. The next model that I'm going to do, next demo I'm going to do is a license detection, a license and vehicle detection model. And this one, I'm going to show you the difference, the performance difference. We're going to use a video on this one. So we're going to show you and this model was created using model retraining. So, and we're going to use that, and I'm going to show you the difference in performance between the Jetson Nano and the Jetson Xavier. And we're going to see both of these are going to be Como's inferencing. and we're going to see that really the Xavier actually really flies when you have it optimized and going. Then just for kicks, and what I want to show, one of the I think really good combinations we have is the RealSense camera is supported within our container, and so is TensorRT. So we're going to go and we're going to do something that Lila did a couple weeks ago, and that's distance between two hands. And we're going to use, again, a hand detection model created with our model retraining system, and it's available in the catalog. We're going to use that model compiled down into a TensorRT format, and we're going to show the Xavier hooked into that, and we're going to get distances using between two hands. I could do more if I had more hands. We're going to see the distance between that. So that's what's up today. And so feel free to ask questions as we go forward. So a couple of big examples to go through today on it. So with that, I'm going to grab the desktop and get started. I think I should just have desktop 1 today. It's asking me questions. So, all right. So let me get rid of Teams. No one cares about Teams. All right. Well, people care about Teams. That's rude. Anyway, so let me get started here. So for the Hacky Hour side, we have all the models, all the applications we're going to do today in a repo. And then hopefully Kamel can get that repo out to everybody. So everything's in the repo and so forth. And just to AB, I know he's out there. I got to get I need him to do his pull request from his again, and then I'll get Eric to integrate it in. I messed it up. So tell him I want to get his stuff into the GitHub too. So anyway, so let's go through and let's go to the dashboard. And I'm going to go to the dashboard, and we're going to do exactly what Kamal was doing. And we're going to come in, and actually, so we're going to create, I actually want to do something first. So sorry. So what I want to do is connect into my Addavier, and I'm going to run, my Addavier, my Nano, my Jetson Nano, and I want to run those commands so we have the best output. So remember those command lines I showed you, how to manipulate the clocks and everything. So I'm going to SSH. That's the first step I want to do because I want these things to run all out today. So I'm going to go into AlwaysAI. Well, I'm going to go into my system, which is an AlwaysAI system. And one of the things I've done today, and again, we can help you with the setup, is I'm going through the Ethernet port on these systems, so I configured and so forth. And the reason is they move very fast. And if you're watching these things on Wi-Fi, trying to go across when you're using the streamer, it will overload the buffers. It will outperform the streamer technique in the Wi-Fi network. And so you'll see frames drop. So I've plugged in today into the Ethernet capability. And again, if anyone wants to know, we'll go to Discord to get people set up. It's really easy to do. So let me log in. And anyway, we're not going to update anything on the platform. So the first thing I want to do, and I wrote the commands out because those who've seen my typing skills are horrendous, and I spend half the time debugging on my typing skills. So I'm going to go ahead and copy. So the first thing I want to do is test to see if the CSI camera is there. So I'm going to run this command. And if you can see, it goes out and it tests the camera, and it tells me my camera is there. So and if anyone looks into that CUDA repo, I have a CSI camera piece up there in GitHub, and it has this command. But again, I will post all this stuff up before on the command and get it copied over and so forth. But anyway, so what this tells me is my camera is running. And I always want to know that when I'm using a CSI camera, because on the tail end, it gets really ridiculous in troubleshooting. So there we have it. I can Control C out, know I have it. So the pipeline works and the camera works and the drivers work. So yay. So the other thing I want to do then is just set up the Nano to maximize its performance. So I'm going to go in and set the power mode so that it operates at 5 watts, the system. So that's its top end. The top end of the Addavier is 15 watts. So these guys are power hungry. So when you want to get the performance and everything, your implementation needs to be where there's power. It's not a low power environment when you use these systems, but you get speed. So that's the trade-off. So I went ahead and I've set the system now. And then the last thing I'm going to do is set up the clocks to work on the CPU. So again, I'm going to cheat here and just do my copy and paste. I'm going to come in and copy that in there. So now, after I do this, so now the clocks are moving up there. And I'll show you, there's a graphical tool called JTOP. And again, we've talked about how to install that in the past, and I'll have that on Discord that anybody wants to know about that. So what JTOP does is show me exactly what's happening. If you can see, the clocks are set on it. So Jetson clock's running, and it's running at 1.5 gigahertz. And then we can also see that this is at 0. So if I went into the info, it can tell you different things, that it is, what jetpack and everything that it's running at right now. But everything is, it's at max power 0. So forth. There's no activity on the GPU because we haven't done anything. But that's just the graphical way to see what's going on there versus the command line. So done there. So I'm going to exit out. And so then what I'm going to do is go ahead now and go back and create a project. And I'm going to call this object detector. So standard, just like what you saw before, I'm going to create a project. So just want to say I've set up my Nano now to execute. So I'm going to create that. I'm going to go view this. And now I'm going to come in and say, okay, let's go do exactly what Kamal did. And let's go install this. And so I'm going to go ahead, and I should already have installed. So I have my TensorRT Hacky hour. So I already previous downloaded from the get. And I'm going to make a directory called object detector. Then I'm going to move into that directory. And this is just organization for me. You don't need to do this, but I just like to be organized so I know what's in what. So I'm going to go ahead and download that system. So it's going to ask me, do I want to create the project from the website? And the answer is yes. And so then it's going to bring in, and then the difference that between what Kamal was doing, I'm going to go out and find my remote device. Now I have these pre-set up. You can go through a setup process. You can either use the save device, which is what I'm going to do, or you can create a new device. I'm going to use a save device. I'm going to come down here and get my first Nano. And so it's going to set up and check the systems. By the way, if somebody wants a quick setup on the system, we do have OS images up when it says set up an edge device on the system that you can download and get your device up and working right off the bat. You don't even have to go to Nvidia to get this one set up. So now I have that done. So now we need to start to use our editor a little bit. Let me get our editor set up. So I'm going to go up. I'm going to reopen a project. And so I'm going to go in and we can see the different things. We're in objects. So I'm going to bring up our app and I'm going to do it. So now we're going to go ahead and morph this into a TensorRT system. And we're going to run it. So we're going to change this over to the Jetson. So I'm going to go back to the web and I'm going to start with the model catalog. And the first thing I want to do is I'm going to go into object detection because we're going to make these around object detection. I have my Jetson Nano highlighted, and I can see that we have hand detection, we have license plates, and so forth. What I'm going to do is I'm going to go ahead and take just the standard Cocoa version 1, and I'm going to detect some potted plants, and maybe myself and cups and things like that. So I'm going to go ahead and do that. We can see that the good news is Eric benches these things, and he's always on the high side. So we're going to actually beat Eric's bench of 56 milliseconds. I guarantee that. So let's go ahead and we're going to add, first of all, the model to our project. So I copy that. I come back to my command line, and I enter and I add that project or that model to the project. And I go ahead and do that. So now I can see I have 2 models. So what I probably want to do just for efficiency, I don't want extra models. I'm going to go ahead, and by the way, if you're sitting there and the first time in, if you want to see all the commands on the command line, just turn it in, and that shows you what all the different application commands are. And if you want to know a lower layer, including the model retraining, just enter AAI of that. So I'm going to go ahead and I'm going to do one more thing because now I've forgotten something. I'm going to do models show, which will show me my models that I have tied with this project. So I do that. So then I'm going to do another command called remove. I don't need the MobileNet SSD and I don't want it part of my project. So I'm going to go ahead and remove that model now. And so I'm going to do models remove, and I'm going to type in where is it from, AlwaysAI catalog. And then the last thing I'm going to do is the MobileNet. I can spell. See, I told you my typing skills aren't the greatest in the world. Really bad for a programmer. So anyway, so I'm going to go ahead and remove that, and we do. And then we can go back and bring back up that command. And now we see with our project, we have a single model. So now I have that, and I've added that model. So now I need to go in and I need to change my program. So we have 2 things we're going to change in the program. Well, 3 things. We're going to change the back end to TensorRT. We're going to change the model to the TensorRT binary. And then we're going to add in the Jetson CSI camera. So let's go forward and do those things. So first I'm just going to do what Kamal did. I'm going to copy that to add to my code. So I'm going to come in here, and when we do object initiation or instantiation, we cite the model as part of that object detection object. And this is true through any of them, classification, semantic segmentation, any of those things. We always, within the object instantiation, we say which model to use. So I'm going to go ahead and pump that in there, and that's got, if we could see right there, there it is. It's in there. Now, the next thing I need to do is change the engine type. So if we go to our documentation, and so I'm going to go over into docs. And so if I go into Edge IQ on it, you'll see there's a constant. And the constants set up what you put in those engines. So for example, this is the constant I'm going to use in this, and it sets up the TensorRT backend system. And I'll show you how easy that is to do. So I'm coming in, and so then I'm going to go ahead and add, whoops, I'm going to go ahead and highlight this and add TensorRT, did I do it right? Nope, I didn't do it right. So TensorRT, I think that's the right parameter. Let me make sure. Sure enough, that's the parameter. So now our engine, which is our inferencing engine, is pointed at the TensorRT system. So now we have that. I'm going to go ahead and save that. I add them. So I save that model, that piece of our code. Then I need to go down. So this is all the setup, instantiation of engine, and so forth. This is just data about it. This is our FPS counter that we have in there. And again, that's all in the docs. So right here is where we set up the webcam in our streamer. And our streamer, for those who are new, that's our output that Kamal showed you. So that's the output. So you can, we call it voyeur mode, so you can see what's going on with the processor and what it's looking at on it. We use we use a content manager paradigm, so you can start these different systems we have with a with. So if you want the file save, it can be started in this too, or you know, you had a secondary camera like a RealSense, you can start it within this because they all follow that paradigm. What I'm going to do is change over to the Jetson. So I'm going to change this over to the Jetson processor. So what I want to do is I want to go back to my APIs. So I'm going to go back to docs. Well, I'm in my APIs. So anyway, so let me go into the Edge IQ ones. And what I want to do is take a look at video streaming. And so I come down and I can take a look at, it's very interesting. We started the error functions, but you can go in, here's the webcam that we're currently using. So I'm going to scroll down here. If you have a GStreamer type interface you need to do, you can use that. Or you can come down here and use this Jetson piece. And so I'm going to go ahead and copy this Jetson. Now, this has got all the different parameters. These are the default parameters that are running on this Jetson, and they can be, if you go down here, we have a whole section on what they are and so forth and how to control that. One of the interesting things about this is it has a rotation on this one, and we'll get into this. That's a rotation object, so it gets real interesting on this part, and you have to make sure you instantiate that object when you're doing camera rotation. So why do I need camera rotation? Well, my camera, and sometimes you'll find this on the Jetson CSI cameras, they're rotated different directions depending on the vendor. Mine's upside down. And you also, something unique is the project I worked on the Jetson camera with was an infrared project. So you're going to see my camera be infrared and upside down if I just did the basic none on rotation. So I'm going to rotate that camera on it. So let's go ahead and just copy that and move back to our code. So now what I'm going to do is come over this and paste that in there. And you can see I have my rotation. So the next thing I want to do, I'm a big heavy code, and just go to the rotation that I need, which is 180. And I'm also going to instantiate that object. I really can talk. Instantiate that object. And so how I do that is like I do everything. Edge IQ, spelled correctly. Dot, and then finally, what's the rotation on this? And then I'm going to use the rest of the defaults on that. So that's how, so now I've changed the web camera to the CSI Jetson camera, and I'm accessing its video drivers to be able to exploit that. And that's all you need to do in the code line and so forth. So we'll go ahead and deploy, and then we'll ask questions. Okay, we'll answer any questions. So let's go to the deployment piece of this, or the install piece of this. So now we have everything, our code set up, everything, knock on wood, and I'm a wood table today, so I can do that. And we'll go in and we're gonna do AlwaysAI, and we're gonna do the install. So this is gonna take the code that I have locally, all the JSON information, configuration, and models, and it's gonna push it on over to the device. So let's go do that. And it'll check to see, so if you're doing it for the first time, it's going to build the container also. That will take a while. I've already pre-done that and brought down the Docker image and so forth. But if you're doing it for the first time, it will go through all that. So those are the steps. So the first thing, it's going to copy the application over to the device. It's going to build the Docker image. It's going to install the model, and then it will create a Python environment. Virtual environment, and then anything that's in your requirement.txt files that you want to add third-party libraries, it will add those at the time. So that's that process. So let's go ahead and do an AlwaysAI app install. Oops, I did an AlwaysAI app install. So let's go through it again just for that, and then we'll probably try an AlwaysAI app start next time. So sorry about that. This is what happens when you deal with somebody over 50. He gets old. Okay, and so it's like dealing with grandpa, right? AlwaysAI app start. This time we got it. Uh-oh. So somewhere I made a mistake in the code. I'm trying to figure out where. I have something that's wrong. I did not like that parameter. Let me take a look again at my thing. It looks like it should have it. Huh? On this.
Someone suggested check the Nano improve memory. Oh, sorry. No, he didn't say that. He's asking a question. Can the Nano improve memory? Sorry, I misread that, Peter.
I'm not sure about that. Let me check on so the Nano can improve memory. It improves usage of memory, that's for sure, on it. And then it improves the overall size of the model. It's going to compress it down, and it's going to extract layers and so forth. So it does a combination of what we call compression and quantization. So boy, oh boy. So let's see what I did. Edge IQ said it did not like my comma. And so I have to figure out why it did not like my comma. So that's right. That's right. Let me be a cheater here. I'm going to go up on Git for a second and look at a previous version that I did. So I apologize, people, on this. This is always the fun part. So let me go look at my example, see what I did wrong in CUDA. So quickly. So this is the other one I was talking about. So let me go in and make sure that I have set up the CSI camera correctly and we don't have an error in the docs. I cannot see where I made my error. So it's not intuitively obvious. So that has something there. It equals 0. So I'm going to cheat. All right. And use this one. So I don't know what I did in my error. So it should be frame rotation. I made up of, okay. So sorry, I made up a parameter. Should be frame rotation. I can see exactly where the error is. So where did Steve make an error? This should be frame rotation. And let me make sure I got it right on it. So whoops. So these are always good. So it should be frame rotation with a capital R. So I made up a parameter. And that's what gets you into trouble when you're using APIs, if you make things up. And so I made something up. So it should be a capital frame rotation. And this should have it work. Yeah, that should be correct. So apologize on that to everybody. I made a mistake. And so we'll go ahead. This time we do have to install again because we've made a change. Make sure I saved it. Yeah, I saved. So we'll go through the install process again. So it's relatively easy to use our APIs when you do things correctly. So on that, so apologize. And let's go with the app start. Yeah, it still doesn't like what I did. All right, Steve is giving up. And so he's going to copy what he had up in that other one. So I just proved that API is not easy to use. I hope people know that. So I'm going to come in and let me go ahead and use that. I don't know what I did wrong. That's what we should have. So definitely increased on size. So I did something wrong, and I'm going to plug out that. And this should work this time.
Yeah, and lots of suggestions here too, like AB saying rotation equals edge IQ dot frame rotation dot
Yep.
rotate.
Yep.
And then Franco says, I think it's mandatory that we explicitly declare the quote rotation argument in Python function.
Yes. So they're right, and right. So thank you for being really helpful on that. So everybody on the thing is absolutely right.
And then there's the best suggestion, the poor man's fix, flipping my camera upside down.
That's true.
That's a great suggestion.
So now we're actually running. So, and again, ignore this warning. It's just something they put up. So when you saw the warning, so the video streamer, but if we go back up on this, so it tells you the engine and so forth, tells you the model, but it has this warning. That warning that's not even worth your time wasting on it. It's unlike the thing. So let's go ahead, and I'm going to go ahead and show people. Here we go. And as you can see, there's some potted plants. And yes, I warned you that that's me on it. But what I want to point out is, remember that big, expensive, shame on you, Tim Cook system where Como was running. We're now beating that system. So we're running at about well, you know, in the high 30s on the inferencing time on this system. So there we go. And again, I can go over here. And yes, this is an infrared camera. There's my laptop every now. Hello, people. So coming through on that. So that's basically taking a standard object detection application, making sure you get the Jetson CI camera rotation framework, instantiating it correctly, as everyone pointed out in the system. But that's how you use it. And that's kind of step one. So we can stop for any questions people might have besides Steve's ability to use our APIs. So
there's no questions written
okay.
out. Yeah, so, you know, anyone who has questions, you can raise your hand or write them out and we can take pauses.
Okay, so then let's go into the next one, which I'm going to go over here. And this is just a standard hand detection system, and it's already set up. So it's going to use the Nano here, and
Steve,
it's going to.
Sorry,
Yes.
Can we stop for a quick second?
Yeah.
We have a question here. How do we convert a model into a TensorRT model?
Very carefully. No. So on this type of model, what you can do is there's a whole series of compilation and so forth. We are going to put that part of our workflow in model retraining. It's not yet. If you have a model that's around right now, either a MobileNet V1 or V2 architecture, SSD architecture, we can go ahead and translate those for you and send them back to you. So it's a big step to do, and we're going to get that fully automated and so forth. So if anyone has that problem, just come to us on Discord or email us, and we'll compile the model for you, and then you can upload it and so forth. But later on, we'll have it in our workflow. So good question. Let's see. So I'm going to do the licensed vehicle detection. This is based on a video that Lila did driving around the neighborhood that she lives in and so forth, and picking this up. And what we're going to do on this one is just kind of give you an idea of what the performance differences are between the different platforms. And this model is going to be the vehicle detection, and it's in a MobileNet V1 state. So that just to tell you what it is on it. And then difference here is we're going to use a video file service instead of the streamer. And then everything else in the code is pretty much the same we did last time. So what I'm going to do is go ahead and first just add that model to the project. Actually, I should show, I may already have it in there. So I'm going to go and say show models. It should, well, you know, I have to end this. So I'll end that first. Then I'm going to go over into my working directory, and we're going to do a similar type of stuff that you saw before. I'm going to go into, I think it's license, vehicle detector. And then we're going to do the AlwaysAI app configure. We're going to run it first because I'm plugged into the Nano. We're going to do it into the Nano first. I'm going to go ahead and create a new project from the command line. And I'm just going to call it, what do I want to call it? Maybe vehicle. and spell that right. And license and lick, I'll just call it. And we'll make the project that. And so it's going to create it. We're going to hit the remote device again, and we're going to choose the Nano. Oops, use the save device. And we're going to get that all configured. Yes, please. And let's see, let me see AlwaysAI again. App model show. I want to make sure I got my model in here. I think it should know that I want it. No, bad command. It's models. Yep. And so then what I'm going to do is go and AlwaysAI app install. So it should go ahead and install these models. So we're going to do that. And if there is, and we should ask, if people want to know how to parse up these models later on and want to go through that type of thing, I can do a Hacky hour on that too. I'm just not prepared to do that today and so forth, but we can do that. It is a process, and you do have to set up your development environments correct on the device itself. So there's a lot of installation process and so forth. You have to have the like TensorFlow all queued up and that type of stuff in it. So and then let's do an AlwaysAI app start. So it's loading up the model right now. And so now if we go into here, what you're going to see is a quick little model of what's going on. This is very brief, but you can see you're running around 29, 30 milliseconds. It's detecting the license plates and so forth on it. So that's the performance on a Nano system, about 29, 30 milliseconds on the system. And if you're doing stuff, you can see, like, let's say I had a robot that was going through and checking in a airport. It would run about same speed you're seeing there, and you can see that quite capable application on this type of system. And usually in a robot in that, you're going to have a nice sized lithium battery that's going to give you the power that you're going to need on it. So that's the Jetson piece. So let's go ahead and say, what would I do to change that model over to work on the Addavier system? So I'm going to make a little cable switch here and redirect my Ethernet over to the Addavier. So the first thing I want to do on the Addavier, so let me go ahead and end that program. Oh, it's not happy with me because I unplugged without exiting. So, okay, so anyway, so let's go ahead. The first thing I want to do again is we need to set up our system for ultimate performance, right? So I'm going to go ahead and SSH once again into my Nano system, into my Addavier system this time, and I know what the IP address is for that. It's fun. What did I do? So let me make sure I did everything correctly. Yep. This isn't going to work. Always, let me do AlwaysAI. Sometimes you just have those bad days with the keyboard, and I'm having one of them. And you probably need an SSH up front if you're going to SSH in. So we have that. I'm going into the 168.3.2. Okay, so again, I want to set the hardware up. And so I'm going to go ahead and enter the power management case. And in this case, and I'll show you what the results are of these things. So this case, I'm going to go ahead and paste in. And so what this is going to do is put it in power mode 2, which is running at 15 watts with all the 6 cores of processors that it has. So it's going to do that in this mode. So on the power side, I'm going to run that command. And then the next thing I'm going to do, and you'll hear the fan light up on this one for sure. This thing runs at 15 watts, so it's a very power consuming, but it's going to haul. And so let me go ahead and get that set. I'm going to go ahead and set the clocks. Now, so what this is going to do is run out the processors at their full speed, the 6 cores that are on there. So that is not a good command right there. That will not work. So let me go back. Got to be careful what you paste. And so now the clocks are running, and again, we can check on those, and it's going to show it's running at the core, and you can see these are up at 1.4 gigahertz on the system, all 6 of them. If you see there's six processors up there and running. So now this system is running at full potential. And so now we have that. So now I'm going to exit out of here. And so then I'm going to manipulate my application to use the Addavier. So what I need to change in this one is simply the model, or what we're calling the model. So what I need to do is find the similar model that has the Addavier, because the binary has, again, been compiled for that architecture. The GPU architectures are different. So that's the key. So I need to go into the model catalog, which we did earlier. And so in the model catalog, what I want to do is I want to now go back one, go back again. And so now I'm in object detection, as you can see that highlighted. And what I want to do is switch and look at Addaviers. So I'm going to go, so I see right here, luckily at the top. This one's pretty close, by the way. Good job there, Eric. On the thing, I'm going to change this over. And I'm going to go ahead and follow the same thing that Kamel did before. I'm going to add this model to my project. And I want to make sure on this one I'm in the right directory. I don't think I'm in the right directory. Yep. So let me go to the right directory. So I think I want this one. Over to my right one. So I'm in my field detection. So I want to add that to the project. So I'm going to go ahead and add the project to the model to the project. And I can do my AlwaysAI, well, it just showed me. So I have that model in there. And then the next thing I want to do is add it to my application. So I come through and copy that on the lower side. And I'm going to add it to my application. So bring that up. And there we go. Bingo. So now we have it, the Addavier model coming in on the system. And I'm going to actually make one other change. And that's, so we have front short. I'm going to do the driving front, because this one goes really, this thing hauls. So I want to show a longer video, if you guys will indulge me. Well, yeah, let's do that. So I have 2 videos in here. This is the longer of the 2. It goes pretty fast. This system really executes, and I do want to see people in an actual driving situation watch it run. So the video did a good job on this stuff. And so now that I've changed all that, let me make sure I saved. Yep, saved the app. Yeah, I saved the application. So we're going to do the install again. And did I run the configure? I bet you 2 to 1 I haven't run the configure yet. So I'm going to run the, let me check my command line. Did not run configure. So I need to configure because I'm choosing a new target. So let me go back. So when you choose your remote device you're targeting, that's when you need to run configure again. So I'm going to run configure again. And so that's where I'm going to say I'm going to use a remote device. And I'm going to tell the system now that I want to use a save device, but it's going to be a different device this time. It's going to be Mr. Addavier. So now we got that. And yeah, that's fine. We use the default directory. So now we have the system configured. Now we want to install. Otherwise, I would have tried to target the Nano again, because that would have been my registered remote device to the project. So I go ahead now and copy the application. Yep, I can see. I like Ethernet because I can see little blinky lights, and so I know it's working. So, and yes, I guess I should have removed that model if I was going to do the elegant thing, but I didn't. So we're going to get both models pushed across, but fortunately it's Ethernet, so it's pretty fast. All right, so let's go and watch this guy run. So remember, around 30 milliseconds, right? Around that speed, is that one? Was the Nano? So now let's go take a look at this guy. Or gal, I don't know what its gender is. So come on, load that model. Okay, there's the beautiful warning message that we all are learning to ignore. And we have a runtime error. So again, we're having lots of typing errors. So what's, okay. So again, I'm making stuff out. This actually has a -A in it. So try again. So you can tell these are live demos, everyone. It's a bad typing day today.
It's great because people can see how to debug applications real time too. So
yeah, best way is not to do those typing errors.
Your mistakes are everyone's mistakes, Steve, and everyone's just learning from you.
All right. Well, Lila and AB don't have those typing mistakes. They're good. I got to get up to their standards here. So there we go. So second try one's a charm. I'm going to go ahead and here we go. And so this is the application running. You can see this is running at 7 milliseconds, everyone. So that is a fast system. So you can see it's finding the car there. It finds the trailers. And now we're going to go driving around. There we go. Hi, car. Hi, cars, I should say. And then this is, everyone, this is, for those who come on our Hacky, this is Lila driving to the shopping center. So see, it's picking up the license plate. But again, I just wanted everyone to see the speed of these systems. And again, this is retail $400 device from Nvidia. And again, we saw how the CPU on the Mac ran, and this is really neat if you look at the speed on it.
Someone just said, "Careful, Lila, there's a pedestrian."
All right, so that was that one. So any questions thus far? You can see the performance difference. So on the Nano, you're looking around about 30 milliseconds. On this one, you're going 7 milliseconds. I mean, this is the inferencing's out of the spectrum right now. So
and you're using the Xavier, right, Steve?
What's that?
You're using the Xavier, right?
Xavier, yeah. The Nano was 20. This is at 7 milliseconds. And again, you can even be very optimistic about what you see in our model catalog. I think Eric quoted this one as 10 milliseconds. So you see, we can beat that. 7 milliseconds. So anyway, so any questions so far?
No, I don't see any questions. There was a question about what, which Jetson you're using, but I think we answered that.
Yeah, so I'm using two Jetsons. So I'm using the Jetson Nano and I'm using the Jetson Xavier. So I'm trying to show differences in how they work with the two. So the last thing I'm going to do is show the Jetson Nano working with the RealSense camera. I know I'm running late, so I don't know. I got to ask the person in charge. Como, is it okay if I keep going?
Yeah, let's keep going.
Okay, so I apologize to everybody about being a little slow here today. So let us go over, and this one should be faster. So I'm going to go down to CD. I'm going to go ahead and do my little check, and I'm going to go distance between hands. So this is the project. So again, now what this is going to be doing is using the RealSense, and I'll move over to that application. So this is going to be using, before I do all the configuring everything, so this is using the wrong model. That's object detection. So let me go up to, so this is using, we'll talk about it, the hand detection model. I need to change that. We do have to do a model change here. It's for the Nano. Everything I put up in the repo runs in the Nano because there's not a lot of people that have Xavier. So I'll have to change the model on this one. And the other thing you'll see in our, where's our with statement, we're initiating the RealSense camera in this case. And all that's in our APIs on it. Quick code walkthrough. So if we take a look, this is simply, I'm using this to find midpoints so I can do writing on it. So I like to write the distance on the system. So when you look at these variables, these are just the best variables I could find for writing the line, you know, to the midpoint so that you can actually see what's going on in the XY axes. So nothing really big's happening there. But oh, the key is I did do this stuff in spatial AI. And so what I'm doing is taking the results and I'm going to move the RealSense camera into what they call point cloud mode. And so what that means, and so one way finding distances to objects you can find to the camera, you can use what they call stereo camera mode. And in this case, what I'm going to do, and we'll look through the code and so forth on it, and we can go back to the spatial ones because of time constraint, spatial AI webinar we had that will go through the detail of this code. But anyway, we're going to hit the point cloud where we're actually going to find the hands in 3 dimensions. And that's using the infrared sensors and everything that the RealSense camera has. So we're going to find the XYZ coordinates, and we're going to find those in what they call the point cloud. So we're going to have 3 dimensions. So when we do our Euclidean calculation, a Euclidean distance, we're going to use XYZ parameters of these of my hands, right, and where they're detected and so forth, and then get the distance between those objects based upon a point cloud estimate. So the object detector that we're going to run is going to find the hands, and then the point cloud system, because we're going to bring back a point, the centroid point of the hands, we're going to calculate the XYZ and then use a Euclidean distance algorithm to figure out the distance in those hands. And it's pretty accurate. I would bet Lila's life on it. So there you go. That's how accurate that hand detection is going to be and so forth. So a little different on that piece. So let's go ahead and I'm going to do the configure. And I know there's going to be questions on it. Just because we're running out of time to do the whole walkthrough of the code.
Is it okay if we take a quick question from Avi?
Yeah.
Okay. Hey, Avi, you're on.
Thanks, Steve, for this demo. This was the demo I was waiting for. Can you hear me okay?
Yeah, I sure can. I'm just kind of laughing.
Okay. Yeah, I think in the midpoint function, I saw you put 0.6. I think it is a typo, maybe.
No, I'm actually uplifting I think the Y coordinates on that, so it's above the line, so you can see the printing.
Oh, okay.
So what I tried to explain, I didn't do it well, albeit, is I was trying to explain that I'm just using that thing to where to put the writing.
Ah, okay, sorry.
Midpoint.
Okay.
So I'm going to actually use the CV2 line to draw the line, and then I'd use put text if we go down into it. And so
Okay.
that's a guesstimate. So you can actually use a 0.6. So I'm raising it off the XY axis and
Okay.
how I'm orienting from that midpoint. That makes sense.
Always. Thank you.
So yeah. So should have been clear on that. It's simply just for the display.
I'm pretty much excited to see the spatial AI and the point cloud thing because I'm actually currently working on that, but not using RealSense, but with the OP. But
the code is up there. Tyga's working on OAK-D, and I'll do a similar. I'll add that stuff into the spatial AI stuff as we get it. So, and then we'll publish the APIs for those that are using the OAK-D camera from OpenCV too. And then, if you have camera requests on it, okay. So, so again, now I've configured the system. I have an early version. I was like first to get an Xavier. I was got an early one from it. So I have an early image, and so for some reason it doesn't detect the jetpack well, even though it's there. So that's that noise. If you do see this error on most and you're using the most updated version, beware, you have the wrong Jetpack version, just to let people know on that. So Eric did tell me to fix that, and I did. So the next thing I need to do is go add the model to the project and make the change. So I'm going back to the model catalog, and I'm going to go ahead and go back into this thing. And then this time I'm going to look for I'm going to go and I'm going to click the Xavier again, and I'm going to find the hand detection model now. I'm going to go ahead and add that to my project, just like we did before. And then I'm going to go ahead and add it to my code. And that should be the only adjustment I need to run on the Xavier in this case. So I'm going to come in and add the model. And then we're going to do a save here. And we should be able to do the install, right? Is that right, Kamal?
I think so, yes.
Bingo. Just make sure I don't run it twice. Cool.
And then we have a question here from Dale. Steve, while that's installing.
Hey, Dale.
Do you expose the power optimization capabilities of the Xavier, such as clock, sleep, etc.?
So again, we allow, so what I did is the way we expose it is using the tool set from the Linux command line tool set from Nvidia. So on the early ones, I set the thing to run out because I'm doing performance testing today. But through the command lines, you can set those by SSHing into them. We did not write an API to do that yet.
Okay.
And there is a way to control it. There's a package called Jetson Stats, and that's the way we would do it. And you can build APIs off it. It's a Python library. So the JTOP that I showed is based on that Jetson Stats library you can go out and get. So that's the question. So.
And then you do start.
Yep. And so let's go have some fun with this camera today. So again, it's right in there. We've had a lot of complaints on setting up from people from the Nvidia community saying, how do I get these two systems running? It's all there if you go to AlwaysAI. So let me go back over to here. We go into here and let's have some fun. There's Steve with his, so let's get my hands up. There we go. Hands up, woo. Go like that, flip it around, finding the center point. I can go like this. Oops, you have to stay in the image. Sorry, it's a mirror image. I have to myself. So there we go. Out we go. I'm going to flip my hands around, and there we go. So and it's inferencing about 7 milliseconds, and so forth. So sometimes it gets, sometimes the accuracy on the model thinks my face is it. So, but not bad. A little bit different than Lila's, but it's catching two things on the red there, but. Model does need some adjustment, but that's it, using the point cloud. Okay, now I'm just having, ooh, look, it caught my elbow. That wasn't good. So there you go. So similar to what, I just didn't do bounding boxes, so similar to what Lila did using the point cloud system. So that's today's thing. So I appreciate those that hung on to see all this. And we moved a little slow today, but
it was worth it. AB's saying that was very cool. So
yeah. Precision, but those again, that can all go through the model retraining and you continue to work on applications on that. But that is using the point cloud to find distance between two objects. So if you look at our APIs on the RealSense camera right now, and again, we'll expand out those APIs to include other cameras. I think Dale's online, so Dale I think can also get with his camera from iCloud. They can do distance camera, and glad to support those. and we have the feature set from them. But if you have a distance camera, RealSense, iCloud, any of the others, you can support that. The two APIs we have, though, if you're working with the RealSense right now, we have distance from camera to object and distance between objects. And so what that allows you to do is build a navigation system using the RealSense camera, or at least build the information necessary for a navigation system. Probably need a navigation system, and then we would be the input to it. So, all right, any more questions out there?
I don't see any more questions, but if you have any questions, this is your chance. Someone just—
and again, apologize to the community for running long. So
no, I think enough people stuck around to see the demo. Jury just said thank you so much for a great presentation, and then Wesley, I will send you some resources for model training after this Hacky hour. Because we had a webinar, so I can share that video with you, as well as how to get started.
Yeah.
All right. Well,
and I think we have a video that's going live too that shows Andreas training it to do watch detection, detect his watch, and it takes you step by step, and then you can start using your own collections, and it should have a collection set for that just to get everyone started on it. So that should be coming up if it's not there already. So,
there actually.
So anyway, I'll let you.
Sorry, Steve. It says any plans to support Connect.
What's that?
Do we have any plans to support Connect? K-I-N-C-T.
What's that now? So Connect.
Connect.
Is that or is that the Microsoft camera that they're talking about? Just
actually, it's AB's question, so I'm going to let him ask.
Yeah, AB.
Yeah, it's the Microsoft Connect. Yeah.
Yeah, we haven't looked into it yet. It's not on the product roadmap. It's certainly the most popular of all distance cameras. So we haven't taken a look. I think probably priority wise, it will be iCloud and OAK-D that come in ahead of that.
Of course, yeah.
So, yeah. So.
Yeah, OAK-D,
but yeah, something to look at.
Yeah, the OAK-D, so the API is still in evolving state. I think they are planning, it's the hardware development, the software development, everything is happening together and people are using as well.
Yeah,
that's very cool. Yeah, exactly.
I'm working with them right now on it, and we totally agree. And so, and we're also probably going to have to put a Python veneer over it.
Yeah.
Things
I'm
like
on
that.
their development branch at the moment, so I just gave it up on the main branch. I went on the development branch and doing everything on that. That's pretty much updated every day. Yeah.
So there's a lot of work. The iCloud's a much more stable environment for those, and it's a professional camera. So if you're going to do real projects, you can be on the iCloud.
Yeah, so, I don't have that. So yeah.
Yeah. I think. So again, Dale is on from iCloud, and he'll be able to help you out. But it's the production industrial strength camera, and it's right now in a. I think I know they're doing a Kickstarter right now. But I think it goes GA in December. So people should check that out.
Okay. I think, yes. Okay.
And Bill has also posted just a link to the camera. So openncc.com. So if you're interested, you can take a look at that.
Thank you.
Yeah, of course. All right. Okay. So I think we're kind of like way on top of the hour. So at this point, I'm gonna call it a day. But Steve, thank you so much for a great presentation. I think everyone really enjoyed it, and thank you to the developer community for joining. And like I've mentioned in the past, we do this every week, so every Thursday at 2 p.m. So if you like presentations like this, definitely be sure to join us next week. And we have a webinar coming up. I will send out official announcements probably early next week. So it'll be November 4th. And we're going to be demoing how you can use some of our new features to train your own computer vision model. So it's a visual model training. That's the title of the webinar.
So it will be adding the Windows platform for sure. And we should be releasing either early next week with the Windows side on it. So there's been a lot of demand. We did it on Linux and Mac. And now we have the Windows system. So,
yep. So look out for those emails, and definitely be sure to check us out next week, as well as our webinars. And Thank you so much for joining, everyone, and we'll see you next week.
Next week.
All right. Thanks, Steve.